In section 3.3, we're shifting our focus from looking at individual equations into now looking at inequalities. So for an equation, we're saying this is true only on this line. For inequalities, we're saying there's way more than answers just on this line. We'd shade above and below, or should I say above or below the line to show where our possible solutions are. So we can make a system of our inequalities then to show where, again, we're finding an area or a certain region where all of those points would work to satisfy our system. So when we're solving a system of inequalities instead of equations, there's some special rules for shading. We looked at shading before in Unit 1, and usually we just said to test a point. Now, for this one, if you can get it down to y is greater than something, or y is greater than or equal to something, always shade above that line. If y is less than or or equal to something, shade below that line. If you want, you can still go ahead and test points just to make sure they work. But trust me, whenever it's a less than, it'll be shaded below. Whenever it's greater than, it'll be shaded above. Same thing with our boundary lines as before. When it's just the less than or just the greater than, you graph a dashed line. When it's less than or equal to or greater than or equal to, that's when it's going to be a solid line. And that's saying that we can have points exactly on this line and in the region, or if it's the dashed line, they cannot be exactly on this line, only in the region. Okay, so let's look at an example of actually graphing these out. If we have our system here, not of equations of inequalities, we have one inequality, y has to be greater than or equal to 2x minus 3, and one where y has to be less than negative x plus 2. Well, the first thing, again, we're treating these as though they were equations. There's lines. We always plot the y-intercept. So if we look at our first one, our y-intercept would be negative 3. We plot it right here. We use our slope to find a couple more points. So slope of 2 would be up 2 over 1, up 2 over 1, up 2 over 1. We can find a couple more points. Or if we went in the opposite direction, it'd be the same as saying down 2, left 1, down 2, left 1. That would continue on. And again, that would make a line, as we see from there. Because we have the or equal to, the line that we use doesn't have to be dashed line. We can just use this solid red line. Go like that. So that's going to be the area or the line, the boundary line for this one. Now, if we wanted to shade a region that would fit there, again, we'd be shading everywhere above because we have the or, the greater than or equal to. So I'm going to use this little highlighter, and we're going to say everywhere in here, this is all of the region that is greater than or equal to that line. So the next place we need to go, we'll look at our second inequality. Y has to be less than or equal to negative x plus 2. So again, we're going to plot our y-intercept. We're up at positive 2 in this case. Our slope, our m value, is negative 1, so that means we're going down 1 over 1, down 1 over 1, down 1 over 1, and so on. Same thing, we could say we're going up 1, left 1, up 1, left 1, creating all of these points. In this case, we would not be using a straight line. We need to make a dashed line because this one is not or equal to. This one is just the less than portion. So we find our line, we draw it out, and again, in this case, we need to shade everywhere that fits that area. So I'm going to use this blue highlighter, and we want everywhere that's less than this line. And we'll notice that there's an area over here where we get both pieces shaded. So this is actually the area, the one that turns kind of the greener color instead of the blue or the yellow. This is the area that would satisfy our inequality. This is the spot where both of those are true at the same time. all of the spots where y is greater than 2x minus 3, and all of the spots where y is less than negative x plus 2. So our solution is just the region that is overlapped by those two shading. All right, in this case, spoiler alert, we're going to have separate regions. Again, just like before, our solution is the region that's overlapped of the two shadings. So we're going to have to graph one line and then shade above or below it, graph the other line, shade above or below it, and wherever they both are shaded, that would be the spot that is our solution, or that area would work for both of them. So if we look at our first line over here, we have y is greater than negative 3/4 x plus 1. We plot our y-intercept at 1. We go down 1, 2, 3, and over 1, 2, 3, 4. Okay, we can't go too far the other way because this only goes out to 7. But if we started at our y-intercept again and instead went up 3 and left 4, we could plot another spot right there. So this is going to be where our line is for our first inequality. And again, that one's going to be a solid line because we have the or equal to portion there. So instead, I'm just going to draw it instead of using those lines. So that's going to be our y is greater than or equal to negative 3/4 x plus 1 line. And then we have this one over here. The y is less than or equal to negative 3/4 x minus 2. So same thing, we plot our y-intercept. Okay, looking at our slope, we're going down 3 and over 4. So 1, 2, 3, 1, 2, 3, 4. Same thing, start at our y-intercept, go the opposite direction. So go up 3 and over 4. That would be our spot. So if we were to continue on or make our line there, it would look something like this. Again, we use solid line because it's the less than or equal to. So now we've shaded, or now we've drawn our line out. Now we need to shade the spots either above or below those pieces. For this one, it says we need to go greater than that red line, so everywhere above it, we would be shading this area. And everywhere above that. So again, I can pick a point. What this is telling us is I can go right here and say at the spot where x is 2 and y is 3, that would satisfy this inequality. I can plug x is 2 and y is 3 into that, and that would come out true. Okay, this is all of the region that makes that inequality true. Looking at our second inequality, though, we need to take this piece. Our y is less than negative 3/4 x minus 2. So I need to go everywhere below this line. As you draw out your lines and shade the area that fits them, you'll notice that these two shadings, or these two areas, do not intersect at all. Okay? Again, all of these points, if I were to go to, oops, don't need that. If I were to take my pen and go to this spot right here, so x is negative 3, y is negative 4. If I plugged x and y in right here, that inequality would be true at that spot. It'd be true at this spot here. It'd be true at this spot here. Everywhere in this blue shaded area makes that inequality true. Well, we can see then there's no spot that would be true for both of these inequalities. You can't get a y value and an x value that's going to make this inequality true and this inequality true at the same time. Okay, there's no way to please everybody in this case. Again, your solution then, you would just shade these two areas, show that they do not intersect at all, and we can say essentially that there's no solution then.